Okay, this is 8.2, arithmetic sequences and partial sums. In this lesson, you will recognize, write, and find the nth terms of arithmetic sequences. Find the nth partial sums of arithmetic sequences. Use arithmetic sequences to model and solve real-life problems. Alright, arithmetic sequences have a common difference. Okay, and we can usually represent these, or we can always represent these as a linear function, meaning that it's going to be a line, and lines have slopes and intercepts. Okay, so this is an arithmetic sequence because it has a common difference. It's adding the same amount each time. And how you find the common difference is you take any particular number, like 19, and you subtract it by the one before it. So 19 minus 15 is 4. Or you can take 15 minus 11 is 4. Or 11 minus 7 is 4. Always take a number minus 1 before it to get your common difference. The common difference is 4 for this one. Okay. The common difference can be represented by the slope in a linear function, and a sub 0 is the y-intercept. This will mean a little more later, but it just means that it's going by this same amount each time. So y is equal to 4x plus b is in slope intercept form, and you can represent these numbers using this, right? Where this would be 1. 1 times 4 is 4, plus some number gives you 7, so the y-intercept must be 3. So 4 times 2, this is my second number, 4 times 2 is 8, plus 3 is 11. And the third number, 3 times 4 is 12, 12 plus 3 is 15, and so on. Okay? But this is the way we're going to write it as an arithmetic sequence. It's not supposed to look like y is equal to mx plus b, but the b is really the, the b is really the one before the first one. So whatever is before the first one is your y-intercept, or a sub 0. Because if this is a sub 1 is 7, what added to by 4 will give you 7? Well, that would be 3. Or you can subtract your common difference by your first term to get your a sub 0. Or 7 minus your common difference of 4 will give you 3. Alright. Is this arithmetic sequence? If so, what is the common difference? 1, 8, 15, 22. Is there a common difference? Well, 8 minus 1 is 7. 15 minus 8 is 7. 22 minus 15 is 7. So there is a common difference. So it is an arithmetic sequence. What about this? 4, 5, 7, and 11. 10. So 5 minus 4 is 1. 7 minus 5 is 2. And 10 minus 7 is 3. Well, these are not the same numbers, so this is not an arithmetic sequence. Okay. Is this arithmetic? Negative 3 minus 2 is negative 5. Negative 8 minus a negative 3 is negative 5. And negative 13 minus negative 8 is negative 5. So it goes down by 5 each time. So this is an arithmetic sequence because it has a common difference of negative 5. But is this an arithmetic sequence? And if it is, what is the common difference? Well, something that will help you do a problem like this is you need to find a common denominator, so you're just matching the numerators. You have to hold something still, right? This has a denominator of 1, this is 4, 2, 4 is jumping all over the place. You can't really know what the numerators are doing. So make the denominators the same. Get a common denominator. Now 4, 5, 6, 7. Well, 7 fourths minus 6 fourths is 1/4. 6 fourths minus 5 fourths is 1/4. And 5 fourths minus 4 fourths is 1/4. So the common difference is 1/4, and it is an arithmetic sequence. So here is your formula. You're going to see it in two different ways. A sub n is equal to, or any term is equal to the common difference times the term number that you're looking for. If you're looking for the first term, n would be 1. If you're looking for the second term, n would be 2. If you're looking for the 10th term, n would be 10. And plus this c constant. That c constant is really the one before the first one. So if you take the first one and you minus your common difference, you'll get c, right? So you take the first term minus the common difference, you'll get the first one. Okay, d is your common difference. Find a formula for the nth term of the arithmetic sequence whose common difference is 3 and whose first term is 2. So what did they just give you? They gave you the first term, which is a sub 1, and they give you common difference, which is d. So d is 3 and a sub 1 is 2. Well, if you look back at the formula you just wrote down from the last slide, you'll notice that using these numbers here, right? The first one's 2, the next one's plus 3 is 5, plus 3 is 8, plus 11. So this is what we're looking at. So the one before the first one should be c, which is 2 minus 3 should be negative 1. Okay, so c is negative 1, or the a sub 0 is negative 1. So you can write that as a sub n is equal to 3n, right, dn plus a negative 1 minus 1. Okay, find a formula for the nth term of the arithmetic sequence whose common difference is 5 and whose first term is negative 1. So d is 5 and a sub 1 is negative 1, and we know that this is going to be negative 1 plus 5 is 4, plus 5 is 9, plus 5 is 14. Using these formulas here, or this one, which is the one I prefer because the c doesn't mean anything to me, and this is easy for me because I just go, oh, okay, what was the one before this one? If I subtract 5 from negative 1, I get negative 6, so that would be a sub 0. Right? So a sub n is equal to 5n dn plus a negative 6. The fourth term of an arithmetic sequence is 20, and the 13th term is 65. Write the first 3 terms of the sequence. Well, if you know that the fourth one is 20, in other words, x is 4 and y is 20, and when the 13th term, x is 13 and y is 65, could you find some kind of linear equation for that? Right? So you have a sub 4 is 20, a sub 13 is 65. Now if you think of this as two ordered pairs, 4, 20 and 13, 65, you should be able to write a linear equation for that. That's algebra 1. So you find the slope, or the common difference, 65 minus 20 over 13 minus 4 gives you 5. So that's your common difference. Now we want to find the first term. Well, in order for us to write the equation, we need the first term. And we know that at any term, or y is equal to mx plus b. So we're trying to find this, the y-intercept. We have the slope, we have two ordered pairs, we only need one of them. I'm going to use this one here, the 4 and the 20. I'm going to say when the term is 20, the difference is 5, and n is 4. And I can solve for c. That's 20 is equal to 20 plus c, so c is 0. So a sub n is equal to 5n plus 0. So you're going to find the first three terms. So you have a formula now. You put in 1, 2, and 3 for n, and you can get 5, 10, and 15. Okay. Here's another one. The 8th term is 25, and the 12th term is 41. Write the first three terms of the sequence. So first we're going to find the a sub n, but we know a sub 8 is 25, and the 12th term is 41. So we find the common difference, which is 4. And then I'm going to use this first set here, the 8 and the 25, the 8 and the 25, with the common difference of 4, and we're going to solve for c. And this is going to be 32, subtract 32 from both sides. I get c is equal to -7, which gives me any term is equal to 4n minus 7. Now I just put 1, 2, and 3 in for this, and I get 4 minus 7 is -3. And 4 times 2 minus 7 is 1. 4 times 3 minus 7 is 5. So it's -3, 1, and 5 would be the first three terms that makes this. Find the 7th term of the arithmetic sequence whose first two terms are 2 and 9. So you want to find a sub 7 when you're giving a sub 1 is 2 and a sub 2 is 9. Okay. Doing the same thing, we have a common difference here of 7, right? And that makes my c constant is the first one minus the common difference, which is -5. And now I have a sub n is equal to 7n minus 5. And 7 times 7, the 7th term, times the 7, my d, is equal to -5. Or I'm sorry, not equal to, but -5. So that's 49 minus 5 gives me 44. The 7th term is 44. Find the 10th term of the arithmetic sequence, whose first two terms are 8 and 20. So we have the first term is 8, the second term is 20. My common difference is going to be 20 minus 8, which is 12. And then c is going to be the first term minus my common difference, which is -6. 8 minus 12 is -6. And then we have my formula, and I want the 10th term. So a sub 10 is equal to 12 times 10 minus 6, which is 120 minus 6, which is 114. This is Carl Friedrich Gauss. He's a famous mathematician, and he's born a prodigy in math. And even at a very young age, there's a really good story about him. When he was 7, he had a math teacher that wasn't very friendly, to say the least. He would say, "Okay, students, I want you to add all the numbers from 1 to 100, and thinking that would keep them all busy for a while. He would go back and start doing his own thing, reading his newspaper already, or whatever he was going to do. Well, before his teacher got back to his seat, Gauss raises his hand. He says, "I have the answer." And the teacher told him, "Stop playing around and get back to work." He goes, "No, I have the answer." So the teacher says, "Well, what is it?" And Gauss says, "It's 5,050. And his teacher was totally shocked at how he could come up with this. Well, Gauss knew how numbers worked, and he would always find a shorter way to do things that seemed kind of tedious. So this is what Gauss did. He knew that he had to add all the numbers from 1 to 100, so he looked at the numbers, just the first few, like 1 plus 2 plus 3 plus 4 plus 5 plus 6, and so on. And he figured, there's a pattern there. Well, there's a pattern going the other way too. If he ended at 100, that means 100 plus 99 plus 98 plus 97 plus 96 plus 95 all the way back to 1. what should equal the same thing. But looking at these two together, he could see that 1 plus 100 is 101. And 2 plus 99 is 101. 3 plus 98 is 101. So he knew that all these added up to 101. If he added every single pair of these numbers, he got 101. Well, he thought, well, that means that there's just going to be 100 pairs of 101s. So he took 100 times the first one plus the last one, right? 100 times 101. And then he knew that that was too much because he added from 1 to 100 twice if he did this, right? He would add the original set from 1 to 100, then he added from 100 to 1 again, but backwards. So he divided that number by 2, and he got 5,050. So because of Gauss, we have this formula. It's called the sum of a finite arithmetic sequence. Finite means that it ends. Infinite means that it doesn't end. So the sum of a finite arithmetic sequence is this. The first term plus the last term, right? The 1 plus the 100 times how many pairs we had. We had 100 pairs divided by 2, because you would have to add all those numbers up twice. So we attribute this formula to Gauss. So using that, how would you find the sum of 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19? These are all going up by 2. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. If you did what he did, you take the first one, add it to the last one, you get 20, and you get 10 times 20, and then you divide that by 2. So that will give you 20 times 10 is 200, and divided by 2 is 100. So the sum of that would be 100. What about this? The sum of the integers from 1 to 150. Well, that will be 1 plus 150 was 101 times 150 divided by 2. Okay, so that will give you 75 times 151, which is 11,325. So this is my summation formula. I'm hoping that that story would help you remember this without having to memorize anything. Take the first one, add it to the last one, and then multiply it by how many numbers you added together, divide it by 2. Okay, so these are some of the things you should try. Not going to go over these right now, except maybe this one right here, the sum of the odd integers. We can go 1, 3, 5, and so on. So it'll be 1 plus the last one, which is 57. That's 58. And just pick how many pairs of numbers did you have. Okay, that's kind of the tricky part, because you're going to have from 1 to 57 would have been 57 numbers, but you have every other one. So that's actually 57 divided by 2, which is 28.5. And because the first one is odd and the last one is odd, you have to round up. So that'll be 29 pairs of numbers. 29 divided by 2. Okay. This is your Google form. Determine whether or not the sequence is arithmetic. If it is, find the common difference for 2, 9, 16, 23, and 30. Number 2, write the first 5 terms of the sequence. If the sequence is arithmetic, give the common difference. Find a formula for a sub n for the arithmetic sequence, given that the first term is 5 and the fourth one is 20. Find the formula for a sub n for the arithmetic sequence. If the first one is 15, then the common difference is 4. The first two terms of the arithmetic sequence are given. The first one's 15 and the second one's 13. Find the indicated term. Find the ninth term. Last one, find the partial sum without using a graphing calculator. So that means you can use a regular calculator or the regular function on your graphing calculator to do this, but don't just put this into your calculator and just have it boot out an answer and you have no idea how to do it without your graphing calculator. Okay, do the math. Now, I want to remind you, my expectation is that you get all the Google form correct, because you should have good notes or good enough so that you can answer these questions. If you can't answer these questions, that means your notes are inadequate. Okay, I expect you to write everything down, but some of you kind of fight me on that, and you write a bare minimum, and then you come and do the Google form and you can't even get them. That means you did not do your job. Okay, and your goal is to take notes so that you can be successful, not to take shortcuts. All right, that's it.